For thousands of years, our ancestors have been looking up at the heavens to look at the stars. In various parts of the world, different ethnicities and civilizations told different stories about the heavenly bodies. They associated them with the gods, dead ones, and heroes and gave them names. But their understanding is extremely limited and vague. Just 413 years ago, in 1609, the Italian scientist Galileo Galilei started a revolution that forever changed how humans view the universe when he turned the telescope, the optical device invented during his time to view the heavens. His observations revealed that there were celestial bodies that did not revolve around Earth. Since that time onward, humans developed an insatiable curiosity of viewing the universe to uncover more neighboring mysteries in our universe. Since 1979, about 90 space telescopes have been placed into orbit. 26 are still active today, and humans are still looking further. Astronomy is now in its golden era, the era of discoveries humanity has never achieved before, the era of deeper and awesome knowledge about the universe. Now astronomers have eyes that can see further into the depth of the universe. Those eyes are the new NASA's James Webb Space Telescope, in partnership with the ESA, or the European Space Agency, and CSA, or Canadian Space Agency. The telescope, in its full capability, is uncovering cosmic features that have never been seen before or that are vaguely seen before until now in full-color images and spectroscopic data. Now, humanity is seeing the most distant galaxies in the early timeline of the universe, seeing beyond our solar system, exoplanets clearly, and seeing hidden yet to be discovered stars in different phases of cosmic history. Truly, the James Webb Space Telescope has opened the door to the glorious era of astronomical discoveries. The awesome diversity and incredible details of the James Webb Telescope's captured images and data will have a massive impact on our understanding of the universe and inspire us to have big dreams. Unknown objects. When people see what has not been seen before, it's first referred to as unknown. Then detailed observation and research make it a known and named object that people know about. That has always been the case with discoveries of previous telescopes that have been sent to space before now. An example is a discovery by Hubble Space Telescope, or HST, the predecessor of James Webb Space Telescope, or JWST. On February 21, 2006, HST saw something that brightens and keeps brightening for about 100 days. 21st magnitude in two near-infrared colors peak, then faded away. It was a mystery at that time because the object did not behave like any kind of supernova before that time. Another example is Oumuamua, the first interstellar object detected passing through the solar system by the Pan-STARRS telescope at Haleakala Observatory, Hawaii, on October 19, 2017. Oumuamua is estimated to be between 100 and 1,000 meters, 303,000 feet long, and between 35 and 167 meters, or 115 and 548 feet in width and thickness. It's interesting to know that Oumuamua's path cannot be captured. Also, the planetary system of origin and the age of its journey are unknown. Now you see the pattern in discovery that whenever a new space telescope is placed into orbit there will be the discovery of new unknown objects. Let's talk about the unknown objects spotted by the James Webb Space Telescope. Because the James Webb Telescope, rightly to be called the successor of the Hubble telescope, sees in infrared, has a bigger mirror, and is equipped with 4 instruments for improved capturing of space images and spectra. It can view very faint, distant, and early objects. This resulted to the discovery of objects not yet discovered before. The unknown object found by the James Webb Telescope is called GLASS Z13, considered a candidate for being the oldest galaxy humanity has ever seen. And it's not like anything astronomers expected it to be. Why is it not like anything astronomers expected? Let's talk about astronomers' prior interpretations of galaxies. It was proven that the light of a galaxy that is extremely far away will be hugely redshifted. By the time the light gets to where an infrared telescope like JWST will see it, the light will be shifted to infrared. By being able to figure out which filters the galaxy appears in or does not appear, astronomers can estimate its redshift and distance. Now, let us come back to GLASS Z13, when it was discovered by the project called Grism Lens Amplified Survey from Space, or GLASS. It's a deeply red blotch and appears to have an extremely high redshift. The galaxy's light appeared to be stretched by a factor of 13 to 14 times, which the code Z13 stands for. The calculation is that Z equals 1 means the wavelength is doubled, Z equals 2 means it's tripled, and so on. The project name with the galaxy's light stretch factor code is what is used to form the galaxy name GLASS Z13. To astronomers, the light we see from Glass Z13 galaxy took about 13.4 or 13.5 billion years to reach Earth, which means we are seeing this galaxy as it was when it was at most 400 million years old. More detailed observations showed that the galaxy already has about a billion stars or more in it, which show galaxies formed stars very rapidly after the universe itself formed. Another interesting thing is that JWST supposes to see a small part of space that was once so surprising to see these galaxies, i.e. Glass Z13 and similar ones like Glass Z11 seen before. Seeing two or more of them in the small space of the JWST shows that they are commonly contrary to what astronomers thought, that ancient galaxies like that are scarce and that models of how these galaxies form are also rare. Another thing to consider is how astronomers believed an ancient galaxy should look like. They believed it should be dark, but Glass Z13 is extremely bright. In fact, it's nicknamed remarkably luminous. What astrophysicists are realizing now is that the early universe might be much busier than they ever thought. Stars may have started forming at a much faster rate than astronomers predicted. These discoveries are challenging all earlier theories about how the universe started to form and the beginning, causing confusion and panic for astronomers. The future of astronomy. James Webb Telescope is designed to see many unseen things and answer many unanswered questions about the universe. To look back in time at the cosmos' infancy and see the first stars flicker on. Collect and focus the faint light coming from the furthest galaxies in the sky. Light that left its source long ago and therefore shows the galaxies as they appeared in the ancient past when the universe was young. We will be able to see the faintest, furthest galaxies still being born when the first sets of stars started to shine. To read the early chapter in the universe's history, the ability to see faint infrared sources doesn't just grant you access to the universe's formative chapter, roughly the period from 50 million to 500 million years after the Big Bang. It would reveal other, arguably just as significant aspects of the cosmos as well, from properties of Earth-sized planets orbiting other stars to the much contested rate at which space is expanding. The James Webb Space Telescope will revolutionize astronomy and cosmology. The more we see, the more we are aware of how we got here, what is beyond, and the very future of humanity's existence. However, we ought to consider one of the most important scientific consequences of having a far-reaching telescope like JWST. With the JWST high-level upgrade, it brings some questions to mind. Is it possible that science models need a complete reset? What about the data sets scientists have been using for decades? Will it be able to meet up to the device's power and accurately interpret what the telescope is capturing? Going forward, opacity models will need to be improved to work on the same level as JWST's incredible revelations, especially calling for crossover studies between astronomy and spectroscopy. There's so much that could be done with the revelations that will come from JWST to perfectly know how light and matter interact, although there's enough knowledge about things around the Earth. As soon as the focus moves to several types of atmospheres, things will change, and there will be a large amount of data with increasing quality that we risk misinterpreting. Now, as astronomers are moving to the next level of Webb's precision, if the translation process is not refined, it will prevent them from catching important subtleties, such as those making the difference between a planet being habitable or not. Extraordinary discoveries will be made, theories will be challenged, knowledge will change, models will be improved, and the future of astronomy with the JWST will be extremely busy and awe-inspiring.